Hey guys, Mike here from ArnoldTutoring.com with a question that asks us to find the local max or min points for this function. Okay, so as soon as we hear maximum or minimum in calculus, we want to instantly think about the derivative and setting the derivative to 0. We saw in the last video that if we see a max or min on a graph, and it's differentiable at that point. In other words, we can find the derivative. It's not like a point. It's not a the bottom of a v, or it's not undefined at that point, and it's differentiable. That derivative is going to be 0. So when we're asked to find the max and the min, we say, okay, let's find the derivative of our function. So our function is some polynomial, and we know that polynomials are actually differentiable everywhere. So we don't need to worry about that piece. But we need to find the derivative, set that derivative to 0, and then find the x values that make that happen. Let's see what happens here. When we set x cubed over 3, when we find the derivative of x cubed over 3, the 3 comes down, x squared over 3, that stays, so that'll cancel. Plus, derivative of x squared is 2x, minus 3, and the derivative of plus 4 is 0, so we don't need to worry about that. So it's x squared plus 2x minus 3. That's the derivative. Now I'm going to go ahead and set that derivative to 0. So 0 equals x squared plus 2x minus 3. How do we solve this for x? Because that's what we're trying to do. We're setting it to 0 to say, okay, there's some x values that make this derivative 0, and those are the x values that on this curve house the max points and min points. This factors nicely. X plus 3, x minus 1. So our x values where there are going to be maxes or mins are at 1 and negative 3. Those are just the values that make the bracket 0. Okay, that's great. So we've said at x equals negative 3 and at x equals 1 there is a local max or a local min. Problem is we don't know which one. So here is where we have to take a very important step and make a table. Basically run in a number line. So I'm going to put 1 over here, I'm going to put negative 3 over here. Those are the values that we found. And we know at these points, I'm going to write it here, f prime of x is 0 at these points. That's what we found, right? We found f prime of x, set it to 0, and we said, okay, at these x values, that's where it's 0. Now what we want to do is we want to test the first derivative with numbers in each of these gaps. So I'm going to test first, I'm going to start here at the left. So I want to test right here. I'm going to pick a number less than negative 3, and I'm going to sub it into my first derivative and see if I get a positive or a negative value out for my derivative. Why do I want that? Well, because we saw in the last video that if we get a negative derivative, the function's decreasing. If we get a positive derivative, the function's increasing. So we're basically going to use what we find about f prime of x, what we find out about f prime of x, to tell us something about f of x. Okay, so I'm going to take negative 10, and I'm going to, once again, plug it right in here in the second derivative. If I put it negative 10, the first bracket's going to be negative, second bracket's going to be negative, so I'm going to get positive. And this is all that matters. You just want to know if the first derivative is going to be positive or negative. You don't care what the sign is. Okay, so if I have a positive first derivative to the left of negative 3, that means my function is increasing. So I'll just draw that arrow for now. It's going up and to the right. How about a number between negative 3 and 1? That's my next gap on the number line. Well, let's pick 0. If I plug in 0 here, I'm going to get a positive value here and a negative value here. Positive times a negative is a negative. So what have we found out? We said, okay, between negative 3 and 1 on our graph, again these are x values, the function is decreasing because I have a positive derivative, a negative derivative. And finally, if we plug in a value to the right of 1, so something bigger than 1, let's say 10, we'll get a positive times a positive, which is a positive. So our function will be increasing. So let's take a look at what we found here. I'll write it in orange. To the left of negative 3, it is increasing up to negative 3, and then it's decreasing after. Right? You can see the increase and the decrease, so that must mean there's a maximum here, a local max at negative 3. Vice versa, the function is decreasing down to 1 as it approaches x is 1, and after 1, where it's 0, it's increasing. So that means this 0 here, we know the derivative is 0 at 1, that must represent a minimum, because it's going down and then up. Last step, if you wanted to find the coordinates, the full-on coordinates, we need our y value, so you plug it right back in to the original function. So we know our, let's actually write our local max is going to be at -3, and then if you plug -3 back into this function, f of x, you will get 13, and that's just, again, by plugging -3 right back in here. And our local minimum, we know the x value is at 1, and if you plug 1 back in here, you'll get 1/3 plus 1 minus 3 plus 4, so 1/3 plus 2, it looks like, which is 7/3. So these are your local max and min. Let's quickly go over the steps there, what we did. We said, okay, we're looking for max min. I'm going to set the derivative to 0 and solve for x. We did that here, and we got x equals -3 and 1. That just tells us that those are the x values where there's either a min or a max. From there, you throw them on a number line to see where it's, and test the points in the first derivative on the gaps of the number line to determine where the function is increasing and where it's decreasing. That will tell you whether the points are minimums or maximums. Then the last step is you plug those x values back into the original to get your y coordinates. You can see this will be a very important step process for us to do once we go to graph functions like this, because we don't know what this looks like, but that's a great way of giving us 2 points that we know are going to be maximums and minimums. You can always send us more questions, info@arnoldtutoring.com. Thanks.